Hello, this is the lesson for 2-5, three-dimensional figures. This was the warm-up from that day. Find the perimeter or circumference and area of each figure if each unit on the graph measures 1 centimeter. Round answers to the nearest tenth if necessary. Of course, they've asked us to find the circumference and the area. So we need those formulas. Circumference equals 2 times pi times the radius, and area equals pi times the radius squared. Both formulas are asking us for the radius. Remember I said do that portion of the work off to the side. So let's identify the radius of this circle, which is on a coordinate plane. And as you can see, the radius is the length from A to B, A being the center of the circle and B being a point on the circle. Well, how do we find the distance between 2 points? Because that's going to give us the radius. We use the distance formula. That represents our radius. We substitute the known values in. We're going to let B be my second coordinate and A be the first coordinate. So that means 5 is my x of 2 and 2 is my x of 1. 5 is my y sub 2 and 2 is my y sub 1. So substitute them into the formula. There leaves us with the radius equals the square root of 5 minus 2 squared plus 5 minus 2 squared, leaving us with the square root of 3 squared plus the square root of 3 squared, which is the square root of 9 plus 9, and the radius is equal to the square root of 18. Now we're ready to plug it into our formulas now that we know it. As a reminder, we do not simplify to the end, so we leave the radius as the square root of 18. So the circumference is 2 times pi times the square root of 18. Simplifying, we end up with the circumference equals 26.7 centimeters. And that is the answer for the circumference. Next, we need to find the area. The area is pi times the radius squared. So in our case, it's pi times the square root of 18 squared, which leaves us with 18 pi centimeters squared. Now, I left the answer this way so you could see this is an exact answer written in terms of pi. But they asked for our answer to be rounded to the nearest tenth, and that's what we're going to do. And so the correct answer here is 56.5 centimeters squared. And that is those are the answers to our warm-up question. All right, so today's lesson, guided notes. You should have a handout. I am going to leave a copy of the blank notes in case you need it in Teams. So there were some key vocabulary and learning points on your formula sheets, which if you do not have one, please, I think I left some at the front table, but you'll have one tomorrow if you don't have one already. You need to pay attention to the key on your formula sheets. The P for perimeter actually is referring to the capital P. When you say a capital P, it's the perimeter of the base of a three-dimensional figure. The small h is the height. The L, the cursive L, is the slant height. The capital B is area of base. Surface area, SA is surface area, and V stands for volume. So when we think about the perimeter of the base, that's that shaded part down there. Do you see that I highlighted? And remember, in this particular shape, there's a rectangle. So remember, whatever length we have along the front, we also have along the back. And whatever we have for the width on one side, we also have on the other. Opposite sides are congruent in a parallelogram, which a rectangle is. Pay attention to those formulas that are listed. You do not have to memorize them. They are on your formula sheet. So let's talk about a polyhedron. A polyhedron is a closed three-dimensional figure made up of flat polygonal regions. So a prism and a pyramid, the prisms and pyramids, are polyhedrons because they're made up of flat polygonal regions. A face of a polygon is a flat surface on the polyhedron. Just as the base is here, all of your sides are the faces of polyhedrons. The edge of a polyhedron is a line segment where the faces of the polyhedron meet. So for example, right there, that is the edge of a polyhedron. And the vertex, of course, is the point. The vertex is the intersection of the edges of the polyhedron, as can be seen here and here and here, and here. There are multiple vertices here. Now, the base of a prism or cylinder are the two parallel congruent faces of the solid. So where I shaded in yellow, that is a base, and then at the top, that is also a base. You have two bases in a prism or cylinder. And then the base of a pyramid or cone is the face of the solid opposite the vertex of the solid. So here, this appears to be a rectangle here, and then here, this is a circle opposite the vertex. So there are 5 different types of solids we're going to talk about. There's a prism. A prism is a polyhedron that has 2 parallel congruent bases connected by parallelogram faces. A pyramid is a polyhedron that has a polygonal base and 3 or more triangular faces that meet at a common vertex. A regular pyramid has a base that is a regular polygon. These are polyhedrons. These are not polyhedrons. They do not have flat polygonal faces because the cylinder, which we have here, has a curved face and a curved surface, and so does a cone. So this is a cylinder, and this is a cylinder, and this is a cone. A cylinder is a solid figure that has 2 congruent and parallel circular bases connected by a curved surface. A cone is a solid figure that has a circular base connected by a curved surface to a single vertex. Now, I like to tell students a prism is to a cylinder as a pyramid is to a cone, because cylinders and prisms have 2 bases, and cones and pyramids have 1 base, and they come to a vertex. Last one is a sphere. A sphere is a set of all points in space equidistant from a given point called the center of the sphere. A sphere has no faces, edges, or vertices. So here are some different types of polyhedrons. Polyhedrons are named by the shapes of their bases. As a reminder, before you may have had prisms before, but they just told you they were a prism. Now we have to name the prism by the shape of its base. This one is a triangular prism, as you see, 2 triangles, those are the bases, and then the parallelograms that are the faces. A rectangular prism, obviously all the sides are rectangles, but 2 of them are the bases, whether you choose the top or the bottom. The pentagonal prism, it's the 2 pentagons that are the bases. And then when we move to pyramids, they're also named by their bases. This is a triangular pyramid, a rectangular pyramid, and a pentagonal pyramid. Using that knowledge will help you to solve problems where they tell you the name of the shape. Now, a polyhedron is a regular polyhedron if all of its faces are regular congruent polygons and all the edges are congruent. So when they say regular, and I'm going to try and type it right here, regular means all sides and all angles are congruent. That's congruent sides. Ooh, that's terrible handwriting. Sides and angles. How about I just write that? Angles. There we go. They're all congruent. Oh, I had it written. All sides and all angles are congruent. That's better than what I wrote. All right, so a little bit of information about platonic solids. These are made up of, obviously, all regular polygons. So there's a limited number of them. So this is a tetrahedron. It's made with 4 equilateral triangular faces. A cube is made with 6, and also called a hexahedron. It's made with 6 square faces. An octahedron is 8 equilateral triangular faces. A dodecahedron is made with 12 regular pentagonal faces, and an icosahedron is made from 20 equilateral triangular faces. So let's look at example 1. It says determine whether each solid is a polyhedron, then identify the solid. If it is a polyhedron, name the bases, faces, edges, and vertices. I told you all, if you remember from class, we're not as interested in naming all of them. I don't want to spend our time there, but I do want us to identify that the faces are polygons and be able to name them. So let's take a look at the first one. This solid formed by is formed by polygonal faces, so it is a polyhedron. There is no base, but the solid has 8 equilateral triangular faces, so it is a octahedron. So it is a polyhedron, and in particular, it's a platonic solid. It is an octahedron. There are no bases, and those are the name of the faces. All the faces of an octahedron are triangles, so they're naming all the triangles. Where those triangles meet are the edges, so they name those. And where the edges meet, and the faces meet, those are your vertices. So this solid is a cylinder. It has a curved surface, so it is not a polyhedron. All right, now you take a minute, you determine whether each solid is a polyhedron, then identify the solid. If it's a polyhedron, don't worry about naming the bases, faces, and edges at this point. But I need you to be able to determine, is it a polyhedron or not a polyhedron? Pause the video, answer the question. Okay, so the first one is a cone, so this is not a polyhedron. The base is a circle, so the solid is a cone. The second one, the solid is a polyhedron. The base is a triangle, so the solid is a prism. This is a triangular prism. And they go on to name all of the surfaces and edges and vertices. All right, let's talk. You have your reference sheets with the formulas, so I want you to use that reference sheet with the formulas on it. They give us some ideas of what those shapes will look like, but use the reference sheet that you have, the handout from your guided notes. Here's the big deal. We have to be able to find the surface area and volume of a three-dimensional figure. We have 2 examples here, and you have plenty to do in your assignment. The first one says, find the surface area and volume of the cone. Round each measure to the nearest tenth if necessary. So we're finding the surface area and the volume. So let's start with the surface area. The surface area formula says capital B, which is area of base, plus pi times the radius times the slant height. It is important that you do your work off to the side so that you can go back in and plug it in. It's to make it organized. Let's solve for the area of the base, the capital B. What is the shape of the base? That's how we determine the area of the base. We need a formula for the shape. Well, this shape is a circle. So now we need the formula for the area of a circle. That's pi times the radius squared. See our circle there? So pi times the radius squared. Oh, so I need the radius. What is the radius? It's 15. It's the distance here from the center of the circle to a point on the circle. They already identified it as 15. So we plug it in, because that's our radius, right? Obviously. We plug it in, and so the area of the base is pi times 15 squared. Remember, we don't want to simplify to the end, so we're going to leave it as 225 pi. So I only squared the 15, and I multiplied it times the pi, but I left the pi in. This is written in terms of pi. So we need that one answer there. The next thing we need, we have the area of the base, we have the radius, well, we need the slant height. So L is the slant height. And so as you can see, that is our slant height there. And I can go on to draw a right triangle, as you see there. And that means my slant height represents my hypotenuse. So my slant height represents the hypotenuse. So I can use Pythagorean's theorem. A squared plus B squared equals C squared. Remember, A and B represent the legs of the right triangle, and C represents the hypotenuse. The legs are the 2 pieces that make up the right angle. So that makes it 8 squared and 15 squared. So that 8 squared plus 15 squared equals the slant height squared. How do we undo the squaring of the slant height? We're not interested in the slant height squared. We're interested in the actual height. Well, we take the square root, because the inverse operation of squaring a number is to take the square root. And if we square root one side, we have to take the square root of the other. That leaves us with the slant height is equal to the square root of 64 plus 225. And simplified, the slant height is 17. So now we have the pieces that we need for the surface area, and we plug them in. So the area of the base is 225 pi, and that's plus pi times 15, which is our radius, times our slant height of 17, leaves us with, and I multiply 15 times 17 to get 255. And so the surface area is 480 pi inches squared. Now, that's an exact answer written in terms of pi. They asked us to round our answer to the nearest tenth. That would be 1,508 inches squared. So that is the first answer. The next thing we need is the volume. Volume equals 1/3 the area of the base times the height. We already found the area of the base. We're only missing the height. So what is the height here? It's the distance from the vertex to the center of the base drawn perpendicularly. They've given it to us. The height is 8. So plugging in what we know into the formula, 1/3 times 225 pi, because that was the area of our base, times our height of 8, leaves us with 600 pi if written in terms of pi, 600 pi inches cubed, but rounded to the nearest tenth leaves us with 1,885 inches cubed as our volume. So we've answered example 3. If you need to go back, rewind, listen to it again, be sure that you're following the process. It's much easier to work your pieces off to the side, the parts of the equation off on the side, and then come back and fill it in. You take a moment, you're going to do example 3. It's probably going to take you a few minutes. It's a different shape. Break down the parts. Pause the video. Then come back and we'll go over the answer. All right, so find the surface area and volume of the rectangular prism. Do you see they told you it was a rectangular prism? So they've told you the shape of the base is a what? Rectangle. Round each measure to the nearest tenth if necessary. So we're looking for the surface area and the volume. So the surface area formula is 2 times the area of the base plus the perimeter of the base times the height. So what is the shape of our base? They told it to us. It's a rectangle, right? So let's just draw that little rectangle. Well, that's the space. And so the area of the rectangle is length times width. And so what's our length and width? It's 5.2 centimeters and 10 centimeters. All right, so that's what we're plugging in. 5.2 times 10, which gives us an area of 52 inches squared. So that was our capital B. Now we need the perimeter. So the perimeter of the base, the shape of the base is a rectangle. How do we find the perimeter? Well, we add up all the sides. I kind of drew a triangle here, and you can see opposite sides are congruent because a rectangle is a parallelogram. Opposite sides are congruent. And when we add them all up, it's really 2 times the length plus 2 times the width, which is 2 times 5.2 plus 2 times 10, for a total of 30.4. So the perimeter is 30.4. And we're not done because we also need the height. What's the height of the shape? It's the distance between the two bases. So what's our height here? 6. Our height is 6. We have all the pieces we need to plug in. And so 2 times the area of the base, which is 52, plus the perimeter, 30.4 times 6, leaves us with 286.4 inches squared for our surface area. Now let's move on to the next piece and find the volume. So the volume here is the area of the base times the height. Really good. We already have both pieces, so we plug them in. The area of the base is 52 and the height is 6, which gives us a volume of 312 inches cubed. Hopefully that's the answer you came up with. Moving on. This just breaks down the problem. This is them breaking it down. If you need to see it another way, I went ahead and solved it so you can still go through it. And this was your check, and they gave the answers. And so here is your mini assessment. See what you can do here. Um, Work that problem out and come back to class with it. It's the second one. Pause the video, work the problem out. And last, your lesson assignment is 2-5 three-dimensional figures. It is due the next time we meet. Remember to pause, go back and watch the video if necessary. Have a good day.